Solving systems of equations. The objective today is students will solve systems of linear equations with two variables by studying how the methods of substitution, elimination, and graphing can be used. System of equations, the intersection point is our solution. So we need to find where these two graphs are going to cross. The first method is substitution. We use substitution when a variable is already isolated or can be easily isolated. So in this case, notice that the y is isolated. Isolated means all by itself. So our goal today is to find an x and a y by solving this by substitution. Here's what I'm going to do. I'm going to box what y equals. So I'm going to box what the isolated letter equals, and I'm going to plug it in for the isolated letter in the other example. So let's rewrite it. 2x minus 2 instead of y, I'm going to use a parentheses. And in that parentheses, I'm going to write what's boxed. Now my goal is just to solve this. Let's distribute. A negative times a negative is a positive 4x. Negative 2 times 1 is negative 2. And bring everything else down. Let's combine our like terms. 2x and 4x is 6x. Add 2 to the other side. So 6x equals 6. Divide by 6. Therefore, x equals 1. So let's fill it into our intersection point that I know now that x equals 1. Well, the next piece I'm going to do is I'm going to take this equation right here, and I'm going to plug in for x. Really, truly, I could plug into either equation, but it's going to be easier to plug it into the one that's already boxed. So y equals negative 2. I know the value of x. X equals 1. Now let's simplify. Y equals negative 2 plus 1. Therefore, y equals negative 1. So my final solution is this point, 1, negative 1. Well, let's try this again. This example does not have a letter or a variable that's already isolated, but I can do it in one easy step. What I'm looking for in those 4 letters is which one is by itself without a coefficient attached. And in this case, it's this one right here. So let's do some manipulations. Let's move this 2y over by doing the opposite, which is adding 2y. So I'm manipulating this equation right here so that it's x equals 2y plus 13. Now does this look similar to the last problem? Our goal is to find an intersection point. So now I'm going to box what that isolated variable equals, which is 2y plus 13. This case, x is isolated, so I'm going to plug it in for x. Let's rewrite this. 5, instead of x, I'm going to have an open parentheses. And in that open parentheses, I'm going to put what's boxed, 2y plus 13. Let's distribute. 10y plus 65 plus 5y equals 20. I have some like terms, so let's combine them. I'm going to add them together and get 15y plus 65 equals 20. Let's subtract 65 from both sides to isolate that variable. 15y equals negative 45. Divide both sides by 15, and y equals negative 3. So I can plug that in for y. My next step is to find the remaining variable. So let's use this equation that's isolated already. X equals 2, y is negative 3, plus 13. So x equals negative 6 plus 13. Therefore, x equals 7. So my final solution is the point of intersection at 7, -3.